Yeah, let's wait for 2 more minutes and then get started. All right, I think let's get started. This is the first working group meeting, 2018. This meeting will be recorded. So yeah, today I plan to give you guys some overview about the upcoming CSI support. So I think the doc has been committed already. So if you go to the master branch on the doc, there's a doc called CSI doc MD, and all the information about CSI is documented there. The reason we want to do CSI, so first of all, for those of you that who are not familiar with CSI, CSI is a specification that defines a set of APIs between container orchestration systems and the storage vendors. And it's a gRPC-based service. And each vendor, storage vendor, will have to define, will have to implement those services, gRPC services, and the container orchestration system like Mesos Kubernetes is going to use that interface to invoke and to call out to the storage vendor's code and to do proper volume provisioning, mounting, attaching, things like this. And the reason we want to do that in Mesos is because if you look at the current support for persistent volume or even like ephemeral volume support, like in general, like a storage support is pretty not that great. We do have a pretty good local persistent volume support where that the framework can carve persistent volume from the root disk, or they can just choose use a mount disk. But the problem with that is we don't really have a good way to plug it into storage vendors' systems. For example, some people say, hey, I want to use Ceph, I want to use LVM. We don't really have a good way to provide support for that. I mean, the only way we can do is ask the operator to pre-config those systems and expose those disks as a mount point in the file system, and then expose that volume as a just as a simple mount point to the Mesos. So that's something that we want to improve. I think external volume support is extremely poor compared to like things like Kubernetes, where the current support is based on Docker volume driver interface, which has a bunch of limitations. And especially around like idempotency requirements. So Docker volume driver interface for most of the interface is not idempotent. It's really hard to make it correct in a distributed system. And also we don't have a way to model external volumes as resources. So right now, external volume support using DVDI is essentially like out of band. So we don't do any fair sharing, quota control on those persistent volume, which is not the spirit of Mesos. These are the motivations why we want to do CSI. I think that interface is a collaboration between these like container orchestration systems like Kubernetes, Docker, Cloud Foundry, and us. And the kind of decision to use CSI is pretty natural, so that we can plug in with any vendor. So this is kind of the high level architecture. Yeah, feel free to interrupt me if you have any questions. So this is the high level architecture of the CSI support. So so there are like two major things that we add to Mesos. One is called resource provider. So SLRP here means storage local resource provider, and SERP means storage external resource provider. So for now, we haven't added that part yet, but the local resource provider has been added. So the local resource provider will talk to agent. So there's a component inside agent called resource provider manager. So each resource provider on that agent will talk to the manager using V1 HTTP API. So we have a public API for that. So in theory, you can write your own resource provider if you want. But we do provide a default implementation for storage called storage local resource provider that talks to CSI plugins using the gRPC protocol that defined in the CSI spec. And the plugin itself is a container, basically. It's a service. It's a long-running service. And then we do have component inside storage local resource provider to make sure that container is always running using the standalone container primitives that we recently introduced as well. The plugin itself has two major services. One is called controller service, and one is called node service. The difference between node service and controller service is that the controller service can be run anywhere in the cluster. Think about, for example, if you're building, like, for example, EBS plugin, you don't have to run the controller service on a particular node that you want to use the volume. You can just run that everywhere. For example, create a volume. You can just hit AWS API to create a volume. You don't have to run that plugin in a very specific node. But the node plugin has to be run on a node where you want to use the volume. The reason for that is the only way you can mount a volume is called system call mount, and it has to happen on a node. Yeah, so that's kind of the general architecture. So basically, the storage local resource provider will talk to plugin and ask the plugin, say, hey, tell me how many resources, how many disk space you have, and then report those resources to the agent. And the agent will tell those resources to master. The master will propagate that to the framework. And the framework can make a decision to either use that resource or convert that resource. So that operation will be sent back to the corresponding resource provider, and then that will translate into a CSI operation like create volume or mount. If you want to launch a task using the volume, then that will translate into a mount API call. Yeah, as I mentioned, we do introduce a first-class storage resource provider. Just keep in mind that the resource provider abstraction is not just built for storage. It can be used for other things as well. For example, we can customize network bandwidth. You can customize like memory storage, things like this. You can use that interface to do things like this to manage your custom resources. So this is like a general interface to allow Mesos to customize the providing part of the resource. Yeah, and also, as I mentioned, that all the CSI plugins are launched as standalone containers. So essentially using the same containerizer that we have inside Mesos to launch those CSI containers that's long running. And then we don't have, we do have a component inside each resource provider to store the local resource provider to make sure that that container is always running. So basically, if that container terminates, it will restart that container. And the standalone container is essentially like some API, operator API exposed on the agent. Any questions so far? No? Okay. So framework API, we add like two more disk source. So if you look at resource disk info source right now, it only has path and mount. So path means that disk that disk resource can be split into multiple pieces, and mount essentially means like it has all or nothing semantics, so you cannot split that disk into multiple pieces. And then we introduced two more as part of the CSI support. One is called block, one is called raw. So the intention for block is trying to support like block devices, raw block devices directly. Like for example, some database wants to use raw block devices. They don't want any file systems to be installed on that block device. So that type is for that use case. And then raw is kind of interesting because raw is a type where the framework cannot directly use. So you cannot say, hey, I want to launch a task using some raw disk resources. That doesn't make sense because you have to convert the raw resources into either path, mount, or block. So yeah, I'm going to talk about raw resource a little more because I think it's a little complicated to understand that. But basically, the rule of thumb here is a task. Any framework cannot use raw resources to launch task. You cannot specify a task with resource that has raw. You have to convert that into either of these three to be able to use that. So that's kind of the rule of thumb here. Yeah, as I mentioned, like raw has to be converted into either of those types before it can be used by a task. And this resource, I mean, the raw resource has like two things that I'm going to mention later. So we do introduce two more metadata into the source of the disk. One is called ID and one is metadata. So this ID maps to CSI volume ID. So if you look at the CSI spec, each volume has ID that's generated by the plugin. So that ID will be the same as that ID. And also, if you look at the CSI spec, like each volume has an attributes, which is like just a key value pairs string of string types. So this one will be mapped to that. So this field will map to that volume attribute in CSI. So these are two optional fields that we add into this source to map to CSI. So also essentially like this is a way to expose like a storage plugin specific information to the framework. Just imagine some CSI plugin that set metadata to some very special things, and those information will be propagated to the framework, and the framework can make a decision based on those things. Yeah, I think the doc have a link to the corresponding CSI stuff. Okay, so now we have two basic concepts that you may want to understand. So one is called storage pool. Storage pool means like you have a, just give you one example for storage pool is like, for example, you have a bunch of EBS storage space. You haven't created volume yet, but you know like you have like 1 terabyte of space that you can carve out. Or you have a local, like for example, LVM volume group, you have a bunch of space and you haven't created logical volume from that volume group yet. So you just basically have a bunch of disk space that you can create volume from. We call it storage pool. And the size of the storage pool is reported by CSI plugin using this interface, get capacity interface. So right now, so I'm going to talk about profile later, but each storage pool must have a profile defined right now. So I'm going to talk about that later. The other type of thing on disk is called pre-existing disk. So there might be some cases, for example, if you have an EBS plugin and then like the operator might pre-create some EBS volume already. And once you launch Mesos and the corresponding CSI plugin, the CSI plugin will detect, oh, there's some volume already exists. So those volume will be called pre-existing disks. Those disks will be reported as raw disk resource still. Within an ID because it's already a CSI volume, so it has an ID set. The reason it's a raw disk is because that how the framework wants to use that disk hasn't been decided yet at that moment. So it can be used as a mount disk, it can be used as a pass disk, or it can be used as a block disk. So basically, no, we don't want to decide that for the framework. We want the framework to decide how to use that disk. So that's the reason we send out those pre-existing disks as raw disk resources as well, but with an ID so that it cannot be carved into smaller pieces. And the way you get those pre-existing disks in CSI is called this list volume interface to get those pre-existing disks. And then we add some new offer operation to do the conversion. For example, once you receive a raw resources, you can reply with a create volume or a create block. So create volume will create convert the raw resources into either a mount or path. So you need to specify the target type here. So you want to convert that into either raw, you want to convert that into either mount or path disk. You have to specify the type here, and also the source, which has to be a raw resources. And destroy volume is just like a reverse operation to destroy the volume. Create block is similar to create volume, except that it will convert the route into the block resource, and destroy block is the reverse of create block. We do have some upcoming support for getting operation feedback, because right now the difficulty for those operations is there's no way you can get a feedback to tell whether the operation is successful. But in the storage case, it's pretty important to get the feedback, because if that operation fails, you do want to know why it fails. What's the error message? You want to surface the information up to the framework so that framework can decide what to do next. So we do have some support upcoming to support feedback. I think most of the code is being wired in master and agent. We just haven't exposed that to framework yet, but I think some people is working on that to get specific operation feedback. So before that, there's some tips to make it work, either using reservation labels or using operator API, but both of them are not ideal. So essentially, we're going to wait for the explicit operation feedback to solve that problem elegantly. Okay, so another thing we add here for CSI support is a concept called profile. Think about profile is an indirection to a set of storage vendor specific parameters. So we have two ways to solve that problem. So one way is like framework make decisions based on those vendor specific parameters, which we believe is not a great idea, because each vendor might have different parameters. It's very hard to write a generic framework to handle that. So what we decide to do is we provide an indirection. So Mesos will, any questions? Okay. So yeah, so profile is like kind of an indirection mechanism so that you can specify. So each profile is just a name, is a string, and that name will map to a bunch of vendor-specific parameters on the disk resources. And each profile can be a simple string like fast, slow, gold, and the framework will make decision based on the profile name rather than those vendor-specific parameters, so that the framework can be general to handle all different type of storage vendors. And the vendor-specific parameter are abstract away, and the operator have to keep that mapping from the profile name to a bunch of vendor-specific parameters. So so that's kind of the field we introduced inside disk source. Has an optional string called profile, indicating what's the profile for that disk resources. It can be fast, slow, go, or whatever the name you define by the operator. And then to customize the mapping between profile name to the actual volume parameters, we built a module interface called disk profile adapter module that the user has to implement that single method to translate a profile to a bunch of profile info, which is a bunch of CSI volume capability and the parameters. So that's how you customize the mapping in your cluster. But we do provide a default implementation which allow you to just define a single JSON file that you host either in an HTTP server or S3 or locally on a file, and you can just define a profile matrix. Say, hey, this is my new profile, and what are the volume capabilities? These are mapped to CSI volume capability directly. So you can define your FS type, you can define your access mode, and also a bunch of parameters related to that vendor. So you can define a bunch of profile here in a file that hosted on an HTTP server, and then within the module that we built in open source will just fetch that matrix and then send out those resources based on those profiles. So we'll set the profile appropriately according to those volume capability and parameters. So there's some flags you can toggle to control the behavior of that module. And this is how you load the module. Right. Yeah. So storage local resource provider, for those of you who join later. So this is a component that we built inside Mesos to support storage. To use that, you have to enable gRPC. So when you build Mesos, you have to do like -- enable gRPC to make sure that the Mesos has gRPC support. So for all the storage features, you have turned on this flag. I guess we don't have to do this right now. I think we can just show that as a demo. There's some comments. Nope. Okay. All right. So feel free to interrupt me if you have any questions. Okay, this is just how we add storage local resource provider to Mesos agent. I'm going to show you in a few minutes in a demo how to do that. Yeah, I'm going to just show you the demo. Okay, so I think that's pretty much it. Let me show you the demo. Can you guys see my screen? So I decided to use DCOS because it's easier for me to make it work. I mean, to deploy that. So I start a DCOS with that feature flag on in AWS. And this is the state endpoint of that agent that turn on this feature. So as you can see, there's one more capability that we need to turn on for this feature. It's called resource provider. So you have, so if you go to flags, so you have to use this new flag called agent features to turn on this optional feature. So by default, this feature is off. Because it's an experimental feature and has an implication on the old persistent volume flow. So I don't want to like change too much in this release. So it's we need to bake one release before we make this a default feature. So you have to turn on this agent feature to be able to play with this feature. And if you go back to the state, okay. So in this, yeah, in fact, for this agent, I use two CSI plugins. So I deploy two resource provider on this agent. You can see that from the resources endpoint. So if you look at reserved resources full, so one row is DCOS storage test. So that's the resource here. It's a raw resource. It's that resource is actually from a CSI plugin called Test CSI plugin that we built inside Mesos repo. It's a very simple CSI plugin, basically carving out directory from a parent directory and the mimic creating volumes. And it has a capacity, like a faked capacity that you can config in the command line. So let me actually share my full screen. I think I have some command line things to show. How do I show the full screen? Can you guys see my terminal?
Yes.
Can I see my terminal? Hello? Anyone
Yes.
there?
Yes.
Okay, let me make it bigger. So I'm on the agent. So if you go to var, actually, where is the config? Okay, so we do have okay, so we do have a directory called resource provider. So so that's a new flag. If you go to the agent flags, yeah, so there's a new flag called resource provider config. So that's a directory where you put all the configuration for the resource provider. So you can drop in JSON file into that directory so that Mesos agent will load those resource provider, storage local resource provider by default. So so this is a directory. So we do have two resource providers that I want to enable. So one is called CSI test, DCOS test CSI. So that's a test plugin. So if you look at the configuration of that resource provider, you specify the type of resource provider, the name, and you have some default reservation. So basically the resource that sent out by this resource provider will have a default reservation. So, but you can leave that field empty. So then that will be unreserved resources. And then for storage specific resource providers, you need to specify the plugin type and name, and then what's the plugin binaries, like what's the container for that plugin. So it's as I mentioned, like each CSI plugin is a gRPC service. It's a long running, so it's a long running service. So test CSI plugin is something we built inside Mesos to test CSI. So the test CSI plugin, you can specify a capacity. Right now I specify 2 gig. And you have a working directory, basically carve volume from that working directory by creating subdirectories. And that's the binary for that plugin. And you can just launch that. And that plugin provides both controller service and no service in the CSI spec. So that's basically a simple configuration for the storage local resource provider. And you just place that JSON file into that directory, and then you can, and then Mesos agent will just load that storage local resource provider and then start to sending out resources reported by that CSI plugin. As you can see here, it's 2 gig. it has a default reservation, and there's a profile here. I'm going to explain that profile thing here a little bit. So the mapping is actually here. So if you look at the flags, there's another flags. Yeah, sorry, I think it's just the module. So yeah, this is DCOS, so we load a bunch of modules. But if you look at this URL volume profile module, that's a new module we add. So basically, you need to enable that module, and the module parameter has a URL that it can point to. It has a JSON file. So if you open that JSON file, that's your profile matrix. So that's your profile matrix. So I define an example profile and what's the volume capabilities and what are the parameters. In this case, nothing. So it's a test plugin, so I specify nothing. And if we go back to state, it will show as a disk has an example profile, has this size. If you have two profiles, it will show two disk resources with different profiles. Any questions? Okay. I do have another plugin that will basically list all the block devices on the box. So I haven't shown you that, but let me show you that. So that there's another plugin called CSI Devices. So this plugin is pretty dumb. Basically, like it will do an LS block on the box and report those blocks as pre-existing volumes. So it's pretty much the same configuration, and just the binary is different. So if you go to the state endpoint, you will see there's raw resources with a given ID and metadata about all the information about the disk resources. Like these are basically the output from LS block, like what's the attributes, removable, type, minor. So you can see all these information about your block devices on the box using a simple CSI plugin. And those are raw resources, cannot be used directly. You have to convert that into mount or pass or block to be able to use that. Now, what I'm gonna do is, it's a DCOS cluster, so I'm gonna start a framework. Let me find out the JSON file here. So we build an example framework to actually test the conversion workflow. So just paste the JSON here. So it's a test framework. So it's inside Mesos too. I think Benjamin is working on to commit that. It's almost there. So it's a framework connect to the master, and there's a role that the framework will register under. It's very dumb framework, basically receiving raw resources and then reply with a create volume to create that to convert that raw disk resource into mount disk, so that framework can launch a task using that. So you run this service in the cluster. Yeah, okay, it's running. So if you go to this frameworks and look at the logs, well, in fact, you can go to Mesos UI. Just click the sandbox. Yeah, if you look at the Mesos on the log of that one, so it will be offered like raw disk resources, and then it will reply with a create volume so that it will convert that raw resource into mount resources. It's a pretty dumb framework. And if you go to stay and refresh that again, you will actually see that there's an unreserved resource, I think, because I think that framework will also unreserve that, so other framework can receive that resource. Yeah, so that resource still showing example profile, and it become a mount disk, and I have a bunch of metadata attached to that things, which is very plugin specific. It does have a provider ID indicating which resource provider this volume came from, and there's some more information about where that volume is. So it's a directory. So and then the framework can launch a task using that resources. We can launch a task, but I don't think I have the marathon config to launch that task. So that's pretty much it. Any questions so far? No? Okay. By the way, so I mentioned like to load a local resource provider. So one way is to drop a config file under that config directory. Another way is trying to use the operator API. So we do build some operator API to allow you to dynamically adding a resource provider remotely.
A question here.
Yeah.
Does the change of operator API be persisted across agent reboot?
Yes, it will be persisted. So the API will just do a simple thing, basically dropping a config file under that directory.
Oh, so agent would actually modify the content of directory on the disk if the
right. So it will be persisted. So next time you start the agent again, it will be loaded automatically. So and we do have an API to remove that if you do want to remove that.
A follow-up, does this also mean the API can even modify whatever previously configured manually on the directory?
Yes, so we do have an update slurp that if the type and name matches, then you can update the container. So basically, that's how we update. For example, your CSI plugin needs to be updated. So that's how you update the CSI plugin version, like to a different Docker container version, things like this.
Thank you.
Any other questions? Yeah, and by the way, we do have authorization for that. So you can set up an echo to prevent people from hitting that API if you don't want to. And as I mentioned, okay, one thing I want to show you here is all these CSI plugin is running as a standalone container. So we add an endpoint called, we improve the existing endpoint, like get containers operator API to show standalone container as well. So basically like this is the curl command. So you can specify the type, get containers, and then you can say show standalone true, and there's another flag called show nested. So you can show nested container too. And you can show both. So in this case, I just want to show standalone containers. You hit that API so you can see the output for, so we have two, since I run like multiple stuff here. So let's start from the top. Yeah, so this one is the framework itself. Okay, so by the way, so show standalone means it also shows standalone, but it's also show the normal Mesos container for executors. So this is the standalone container that we create for devices. I have two plugins, so there are like two CSI standalone containers. So one is called CSI devices, and you can see the stats for those. And then there's another plugin, standalone container DSS test CSI using a test plugin. And you can see the stats for that plugin. So it's the same containerizer handling those standalone containers, similar to executor containers or nested containers. So you can view those containers. And then there's a component inside Mesos slurp to restart those containers if it fails or something like this. Any question?
Two questions here. The number one is how to distinguish between a regular executor container and a standalone container? Is there executor IDs somewhere in the response?
Well, first of all, if you don't set show standalone container to true, then it only shows executor containers, like the same as it is right now.
Yes. But if I set that to true, how do I interpret which one is from standalone, which one is from a framework?
So right now, we don't have so there's no executor ID, so only have container ID. So that's one way you can tell. But it's not very explicit. So maybe like one thing that we can do is make it more explicit. So this is standalone container.
Of log a task. Thank you. Another question here is nested this is a list, not a tree for nested container, right?
Right. So even if you say show nested container, yeah, we can do that here, but I don't think we can show any nested container. I can launch a pod using that. But anyway, so yeah, for nested container, yes, so it will be a single list, and the container ID you can infer the tree structure by looking at the container ID field.
Okay, thank you.
Because each container ID has a parent if it's a nested container. Mm-hmm. So you can infer that if you want to.
Okay, thanks.
Yeah. Any other questions? Okay, so I think all the piece has been committed in 1.5. So 1.5 is going to be released hopefully this week. There's some bugs that I need to fix for some other stuff not related to this, but we're going to wait for that to be landed. And then, well, there's one more bug that we want to fix for this. But once that's landed, then we're going to cut 1.5, and that we have this experimental feature you can use. We're going to improve that in the future, especially supporting global resources. As you can see here, only local resource provider is supported right now, which allow you to do things like LVM, but the ultimate goal we want to achieve is trying to support things like EBS, which allow a volume to be moved between nodes, not tied to a particular nodes. So that's the eventual goal we want to achieve. But all the stuff we built so far, it can be reused for external providers and external plugins. So, and stay tuned. The doc is there, it's committed. If you want to play with that, follow that doc. All right. Any other questions?
A question / feedback.
Yeah.
So I see LVM has been extensively mentioned in this document.
Yeah.
It's a little bit hard even for me to connect all the dots end to end to understand how to launch something with a LVM volume. Will there be another Eng blog or something like that, or tutorial or something like that to show people how that works? Yeah,
so that's the plan. We plan to actually like these two. So Mesosphere open source the LVM plugin. So if you go to Mesosphere LVM, CSI LVM. Yeah.
Nice.
So that's the LVM plugin that Mesosphere open source. It's a CSI plugin. Yeah, so we probably want to write a end-to-end tutorial like documentation to walk you through how do you enable LVM and how do you set up those things to make it work. That's a good suggestion that we should definitely do.
Yeah, that's awesome. Another question about the resource local provider.
Yeah.
Is it only limited to CSI or storage stuff? And if yes, is there a plan to expand it to other type of non-storage resource?
Yeah, so I think you joined the meeting late, but yes. Yeah, I mentioned earlier that resource provider interface is not limited to storage. Storage is just one implementation of the resource provider interface. We can potentially use the same interface for other things like network bandwidth, ENI, like all sorts of resource that you want to customize.
That's awesome.
Yeah, and I think the interface itself probably not that straightforward. So I think one thing that we may want to do is, for example, for special type of resource. For example, one thing that I'm planning to do is for devices. We provide a default implementation called a device resource provider that talk to some plugins that providing those devices resource like FPGA, GPU, TPU, whatever those custom ASIC devices, and make that implementation for the device plugin very easy. So that the user wants to customize their devices, just need to write a device plugin, which is similar to writing a CSI plugin, which should be pretty straightforward because it's a well-defined gRPC interface, and you can use any language to write that.
Okay, since you mentioned device, then for example, for the case of GPU, since that's already in vanilla Mesos, GPU. So right now, the resource providing part is kind of just provided by Mesos, but the actual runtime isolation, runtime mechanism is provided by the isolator. In the future architecture I'm mentioning, what's the relationship between the isolator and the LRP? Yeah, so that's a good question. So isolator is useful for isolating resources. It's kind of orthogonal to resource providers. They're related. Like resource provider responsible for providing resources, and you probably want to have a corresponding isolator which is responsible for isolating those resources on a single box. So I view these two as a pair thing that you have to deploy simultaneously to make sure that providing part is customized by the resource provider interface and isolation part is customized by the isolator. So in the SLRP design, it's mostly just responsible for providing resources, probably in a Scala or quantitative way, and the Mesos will still do all the resource counting, allocation, rename based on task or container lifecycle. Yeah, yes. If you see the state endpoint, those are regular resources that are still subject to resource allocation, code and fair sharing. I see. Thank you. Thank you very much. Yeah. So that's the whole purpose, that we don't want to make an exception. Everything inside Mesos is modeled as a resource and is subject to the same fair sharing, quota control, reservation control. Yeah, thanks. All right. Any other questions?
Okay, so if you have any further question, feel free to reach out to us. Happy to answer any question related to that. Okay, so I do have another. Wait, hold on.
Yes, I have one extra question. Like, what's the relationship between create volume API and the old create API?
Yeah, so that's a good question. I think it's explained in the doc. It's a little confusing because the unfortunate case that we use create for the old API, which this one, it should really be create persistent volume. So create volume basically converting raw resource to a mount path or a mount disk or a pass disk, and create persistent volume convert a mount or pass disk to a persistent. So a volume can be either persistent or ephemeral in the future. So in order to use that, I mean, if you want that volume, the data in that volume to be persistent across tasks, then you have to create persistent volume the same way as you do right now. To create persistent volume, just the source is whatever the new disk resource that you receive.
I see. So we're probably going to start a deprecation/rename cycle in the future for these two?
So we probably deprecate this and add a new one called create persistent volume, and then deprecate this too, because the naming is so confusing.
Yeah, thank you.
Right. Okay. Anything else? Okay, so I think we have 15 minutes left. I don't know if we have time for this. Maybe you can leave that to the next time. So the next time, what I plan to do is we probably do some planning for 1.6 release. Like, just want to get a sense like what feature that people want to work on, any like resource we have in this working group that can help review and get those things shipped in 1.6 or even the version after that. I think we have a bunch of design documentation listed here. I'm not sure what's the progress for each of those. I think it's here. I'm not sure if it's accurate, but yeah, let's do some grooming and the planning for this current release next time working group meeting to decide who can help on what, things like this, and how much time each person has, so that we can planning which feature we can ship in the next release as a group. That makes sense. Okay, I think that's pretty much it for today's meeting. Thanks for attending. I'll post the video to the YouTube and the link to the notes. And Happy New Year. I think that's the first meeting we have in 2018, and hope you enjoy the vacation, and let's build some awesome software in this year. Thanks, guys. See you guys. Bye-bye. Bye.